about it. Okay. All right. So let's see. Last week of the quarter. Thank you for everybody who turned in their SLP final upload, final report this morning. I started looking through those. They look great so far. So I get those graded somewhere in the next few days, and then remember that an upload of your presentation is due tomorrow. And again, if you want that to be private, obviously upload it with an unlisted link. And in the beginning, make a statement whether you want this shared publicly or kept private. And I will get to those later on this week. I doubt that anyone's report is too bad, but I will definitely look at it. Yeah, so hopefully the SLP, I know it's viewed as kind of, a pain because it goes for 3 quarters and there's not a whole lot of sort of checkpoints along the way, and so it tends to sneak up on students towards the deliverable dates. And so, sometimes people come away from the experience thinking, I'm glad that's done. I hope I never have to do that again. But it's a good representative of what a lot of things will be in your careers and in your life, where there's this slow burn background thing going on that you have to keep up with, but you're not necessarily accountable for until certain points in time. But got a lot of back and forth with students on their projects. Looked like there was a lot of innovation going on, a lot of learning. A lot of people who are computer science students getting into hardware, right? Buying parts and hooking up Arduinos and learning to solder and learning about the dark side of reality, which is that, you can draw a circuit and analyze it, and here's what should happen. And when you build it, something totally different might happen, and that's either unfortunate or a really exciting opportunity to get into new stuff, depending on how you look at it. So hopefully people had a good time with this project in the end, and some people are going to continue working on it down the road, which is awesome. I think projects are one of the coolest parts about being in school, because if you can get credit for working on something that you want to work on, right, that sort of beats doing homework that's assigned to you, at least in my book. All right, so PA5 is graded and back to you, and so if you know how to use the raise hand feature, right? How many people found PA5 to be difficult, or if you want to put a chat message, how many people found PA5 to be like really challenging? Right, like a step beyond what we had done in the other assignments. Like staying up until 5:30 a.m., for example. So yeah, this was an ambitious assignment. It's not an assignment I've given before, and it's I usually do an assignment that involves networking, but it's usually pretty straightforward. Right, make a connection and send a message and get a message back, kind of thing. And this was less rigidly defined and integrated into an already fairly daunting project, which was PA4, and required a separate thread and all this kind of stuff. It was a lot of pieces, okay. And my goal in this assignment was really for people to go through the process of thinking about a large-scale project from a higher level, and work with how to organize things, how to take advantage of objects, how to put the pieces together and how to test it, and so on and so forth. And if your mouse clicks didn't get mirrored perfectly or something like that, or you couldn't figure out how to manage the connection in all cases, that's fine. That's the sorts of issues that one expects in this kind of thing. But it looks like people, got out of it what I was hoping, which was sort of this higher level perspective, and and this idea of taking things and putting them together, right? And so this is a great comment from someone. It was hard until it wasn't, right? If you happen to be doing this in a way that lends itself to further development, you may find you reach a point where suddenly it becomes a lot less painful, right? Even pleasurable and fun to add more and more to this. But that's if it's being done in a way that lends itself to that kind of continued development. And so this is where I made a comment that sometimes you get a certain point in the project and then you find, hey, I really should have structured it this totally different way. And if you have time, right, and you go back and you restructure it with what you know now, you may find it's a totally different experience writing it, right? And so I've talked to a few people about this. Even though the assignment is turned in and graded and so on, come and talk to me if you want to brainstorm on sort of the overall design and how that might be tweaked. And in some cases, it's just a little bit of tweaking that might make a totally different set of code that suddenly you find lends itself very naturally to extension and further development. I will say the most common problems I saw, and I'm kind of delighted that this was the most common set of problems. The most common issues I saw were a bunch of people did not put their name anywhere in the code, right? / did not write any comments, right? And I didn't require particular commenting on this, but I would like to see people's name in their code. A lot of people named the class wrong. I got dot, I got dots, I got net dots. Instead of just plain old net dot and so on. There were several people who submitted code that would not compile because they didn't check all of the .java files in. People didn't set up the right default client and server name, right? And this is awesome because those things are totally fixable, and actually I did not ding people for these things because I want to know, do you understand objects, Java, sockets, threads, swing, paint, repaint, that kind of stuff, and what I was seeing, people understand this stuff. So, but with a disclaimer that make sure, particularly as you leave Clark, if you're leaving this year, make sure you really, really, really follow the directions on an assignment, right? Because if you don't name the class correctly, you get a 0 after 2 weeks of working on something, right? And now you're not sure you're going to pass the course or something. So, don't take anyway, follow directions in the future as best you can because it'll be increasingly important in higher level courses. So yeah, a comment from someone, Paint has no documentation, which makes it annoying to mess around with. Yeah, Paint is a remarkably open-ended method, right? It's something we don't normally mess with, yet we can do so many things with it. And the only way that I figured out, the details of Paint was by just writing lots of test code when I was learning this stuff. I had never encountered something like this where you override this method and suddenly things are appearing on your screen. I was used to procedural code where you want to draw a line, you say draw a line, you want to draw a circle, you say draw a circle, and all of a sudden you're doing this weird, set things in the paint method and call repaint. It takes practice, but messing around with it more, right, makes it more comfortable. And when we play with Android tomorrow or Wednesday, you'll see the same kind of thing in Android, right? Different specific names, but same idea. There's a method that you override and it gets called when things need to be redrawn. But yeah, the lack of documentation can definitely make it frustrating to work with. But write lots of test code. And for a while, when I started teaching this course, every time that I got to this section of the course, I had to relearn all this stuff. Right, and now I've done it enough, and I do it enough in sort of my daily life that it has sunk in. But the concepts are different from, you know, a lot of what we've done in the past. So it definitely takes some getting used to and takes a lot of practice. But I think people are doing a great job with it. And yes, if you're in Eclipse, you know, and you have the suggestions turned on, which they are by default, you can type something like, you know, G, the graphic argument to Paint, G period, and it'll bring up a list of possible methods you can call. And you can mess around with those, right? And those are the same methods that you find in the Java documentation. But the Java documentation you gotta be a little sleuthy about, right? So here's the methods that are part of the graphics class, but those aren't the only methods you can call, right? Well, graphics isn't very interesting. It inherits all of these other methods, right? But if you were to look at something like, you know, a JText field, it's got a bunch of methods you can call, okay? But you notice there's no setText method in here, right? Because setText is inherited from another class that this one extends. So for example, if you look down in here, you'll see getSelectedText and so on and so forth. So there's you know, more methods than you find just under the method listing in the documentation. But I think these will show up in the list of suggestions when you're typing in Eclipse. So that can be a useful way to explore. All right, let's talk about PA5, some of the pitfalls that people ran into and some ideas for managing those. Probably the biggest trouble point I saw for people boils down to, I think, the order in which things are done, or the place where things are done. So for example, I saw you know, some people's code where you know, you might click over here and see a line, but the corresponding line over here doesn't show up until you click somewhere else. And then when you click here, you see this line and also this line. And maybe this line doesn't appear until you click up here, and now it suddenly shows that other line from the other player and so on. That kind of thing happened in some cases. And it's probably a question of when are you calling repaint, right? So repaint is what causes this to appear, and if you want to know if that's the issue, you know, click here, draw this, you get your initial down here. If you look over here and you're not seeing that, try resizing the window. If that makes your missing lines appear, then you're probably just not calling repaint at the right time. But if it doesn't make the lines appear, then chances are you're not sending the information, or you're not receiving the information about the mouse click in time to display it here. So what do? Add some debug statements maybe. In your code over here where you send the coordinates, where you say coordinate x, y, throw a print message in, right? And say, hey, I'm sending the coordinates now. And over here, when you read and process those coordinates, put in a print message. And now click on your line and see, are you sending them? And if you are, see, are you receiving them? And if not, right, you know, go from there. I think there were some cases where to do some operation to update the score or change whose turn it was or something, you might need to do a series of steps. Step 1, Step 2, Step 3. And it may be that Step 1 was being done too soon. For example, checking to see if the score had been updated before you modified the data structures, right? So you do S1 and then S2 and then S3. And really, it's not going to update your score until you do another S1, which might not happen until the next mouse click. So these are questions of organization, right? These are questions of how did I, set up the sequence of steps, or maybe how did I organize my data. And with a large program, right, it gets that much harder to figure this stuff out. And writing code is in some ways easier than reading code. And even though we're the ones writing it, we can have a hard time reading it, especially if it's written over a period of time. So what can we do to increase the likelihood of figuring out what's going on and having the right things happen in the right times? Think about your data. Okay, this is a course in data structures. And it's a course in Java. It's object-oriented design, right? And the idea of an object is really, taking your data and your code and bundling them into an object. And it's not just random data and random code we put into classes just because we're supposed to have classes, right? The data goes with the code modifies the data or reads the data and responds to it. They really are the things that belong together naturally. Okay, that's the first thing. If we can minimize having a bunch of functions and a bunch of data, and the functions, read and modify the data, if we can avoid that kind of structure and think more in terms of, here's a set of code and data that go together, here's a totally separate set of code and data that go together, right? We can clean up some of our organization of our code. So let's talk about statics, also called evil statics on the web sometimes. Statics are an easy way to create globals, okay? And we usually tell people not to use global variables. Okay, I know teachers who, if they find a global in your C program, you get a 0 automatically. We're told globals are evil, and we joke about it and stuff like that. But statics are really the way that you can create globals in Java. Right? We can say static integer, player 1 score. And if we define that in a class called, main, then we can say uppercase main dot player 1 score. And it refers to, this one copy of this integer that everybody can get to by just saying name of the class main dot player 1 score. And that can work, right? And sometimes that's, a reasonable seeming thing to do. But it is a global, okay? It's a variable that can be accessed from any method, any method running inside any object at any time. So what's the downside of having globals? It's this kind of thing, code and data that seemingly have nothing to do with each other, right? So suppose you use a global variable for each player's score, okay? And you run your code, and this player completes a box, and their score is updated, but over here, the score is not updated. Or let's say, you have something like this, and the player completes this line right here, and they get 2 boxes, and the score only gets updated by 1. Okay, if your score is this kind of global variable, it could be getting updated from anywhere, right? Any method in any class, you could have written something that, updates this score. And so you might have 5 or 6 different places, and you have to go through and check each of those and figure out which one isn't being called correctly. Or maybe you decide you're going to add a 7th place where, when you complete this, you're going to see if you added 2 boxes, and if you did, then you're going to say, player 1 score plus plus. And it's making your code more complex. It's going to make it harder to debug down the road, especially if you came back to it after a month. It's also potentially problematic if you're developing in a team, right? Because if this is a global variable, right, how do you know who's updating it and when and how? And if you want to update it, do you just go ahead and increment it? Well, what if somebody else has read this and is, you know, in the process of modifying it? And it gets away from the idea of objects, right? The idea of an object is take this data and bind it to, you know, the code that's going to interact with it. So the fewer statics you use, right, and I would say aim for 0, right? The fewer statics, the better. And to some degree, the fewer variables, the better, right? So there is one kind of static that is appropriate, which is if you say final, you can define a variable whose value cannot be changed. And this is a good way to declare constants. So if you say final static, you know, box size equals 50 to say I want my boxes to be 50 by 50, that's a good place to use a static, because now, you know, if this is inside the box class and I want to know how big should I draw my box, it's just box.box size. And everybody should be able to get to that, and you'd like everybody to use the same variable, but nobody's going to change it, right? The keyword final says this can't be modified. And so you can see in the code what the value is, and you can know that's never going to change. But then if you decide you want to make a program with, you know, 75 by 75 boxes, you can just change this one final variable. Alright, so let's go back to number of variables. Suppose you store your score in 4 different variables. Suppose your box class has a score, and your game panel has a score, and your net.dot has a score, and your thread has a score, right? You have a daunting task, which is trying to keep all 4 of these things in sync. So I took a database course when I was an undergrad, and I don't remember a lot from it, but one thing I remember was the notion of avoiding redundancy of information. Right? So the person who wears 2 watches never knows what time it is, right? Old adage. If you have that score stored in 4 different places, you have to keep them all in sync, right? And if they're in sync, theoretically it doesn't matter which one you look at when you're trying to update the score or see who's winning or whatever, right? But, you know, anytime you do something that's going to now modify the score, you've got to make sure all 4 of these scores get updated accordingly. And it's a future bug waiting to happen in a lot of ways. So somewhere between having 4 or 5 copies of a variable and having a single global variable, there's a solution, right? And the solution is to make one copy of that variable and put it inside the class where it most logically belongs. Okay, well, where does, say, the player's turn belong, right? I don't know. There's lots of different classes that use it. It gets handled by the net thread, it gets handled by the mouse click, it gets handled by the paint method, right? But I think the way I usually think about it is you have something that's being accessed by multiple places, but hopefully being updated in one place, right? Or one primary place. So for example, whose turn is it? That's probably updated in response to a mouse click, right? You click the mouse and you make your move, and if you didn't complete a box, now it's the other player's turn, right? Or you get coordinates from the other player and you update your data structures, and if they didn't complete a box, then it's your turn now. So thinking about that, maybe it's not the mouse click, maybe it's the code that's responsible for updating my booleans in my box array. Or maybe after I update my booleans in my box array, I run a piece of code which says, did somebody just complete a box? And maybe that's where I take the responsibility of keeping track of whose turn it is and put it in that code. And if we can be data driven, right, data objects, data structures, if we can be data driven, that's even better. So here's your array of boxes, and inside each of these elements you have a top, a bottom, a left, a right, the person who owns it, and maybe some other information. Well, suppose you go through and you update, you know, the edge booleans in your entire array based on the mouse click. Okay? And don't look at who's completing boxes yet. Just update the data structures and think now, okay, my booleans are set correctly in here, but I haven't done anything with the who. Well, now I can have a separate method that, you know, takes this array of boxes and goes through and looks at each box to say, is the box completed? And if the box is completed and the who field is blank, what do I know? Somebody just claimed that box. And now it doesn't matter if they clicked up here and it completed this box, which was different from the box they actually clicked in, right? I've separated this task of updating the owners of the box from the task of figuring out where the click happened. Okay, more modularization. So mouse click is just updating these things, and then I'm going to run a separate method which will update this, and in that method I will note if this is changing from unowned to owned. And if it is, then I know that whoever just made a move completed a box and it should still be their turn. So I might put the code that's responsible for telling me whose turn is it for updating that inside this method. And where do you put this method? Well, that might go in the class where you have your mouse handler, right? Or I could make a totally separate class for the actual board itself, and that class could contain the array of boxes and the method for updating the booleans based on the XY position of a click, and a method for checking to see if anybody new owns a box and returning a boolean. And while we're at it, we can figure out the score like this. So back to this idea of avoiding redundant information, instead of having a score variable, what do we know? The score is always the number of initials you have and the number of initials I have. Well, that information is stored in this array. It's in that variable inside each box object. So instead of storing the score as a variable, let's make a method. Let's make a player 1 score and a player 2 score. And when I call player 1 score, what will I do? I will loop through each of these and see if the who field is set to player 1. And if it is, I'll increment a counter. And then I'll just return that. And suddenly it doesn't matter who has updated this structure. Doesn't matter whose turn it was. Doesn't matter if one box or two boxes got completed by this single click, right? Because when I want to find player 1 score, I'm going to call this method, which is going to loop through here and count up the number of times that a box is owned by player 1. So if you think about those kinds of things, right, using methods to access information instead of trying to store values of variables, right, you may find that lets you think about your code differently, and it might let you make cleaner versions of your code if you go back and try to modify some of this. You may find that feels cleaner to you. So those are just some things to keep in mind down the road, or if you decide to work further with PA5. And this is the kind of thing where, you know, maybe it'll be hard until it's not anymore. because once you no longer have to worry about, you know, whose turn is it, I can just have a function called, you know, whose turn, and I don't have to think about, you know, what the variable is and where it's updated and so on. Then it starts to get really fun to play with this stuff. And again, when we look at Android later this week, we'll see, you know, an environment where a lot of this stuff exists for us, and we don't have to work too hard to do it. Like if you want to know the GPS coordinates of the phone, right, you can just call a method and things like that. All right, so I don't know if that's helpful or not, but those are just some thoughts. Sort of a higher level discussion on some of this coding. All right, any other questions on PA5 or anything? Objects, Java, if statements. All right, and I have office hours this week as usual, if you want to look at your code. Yes, quick SLP question. The doctor of the presentation says it should be 5 to 10 minutes. Is a little over 10 minutes okay? Absolutely. Those are approximate targets, but if you want to talk for, you know, a half hour about your SLP, I'm very happy to listen to that. What I didn't want was a 30-second presentation, so that's the reason I put 5 to 10 minutes on it. But yeah, take as long as you like. And I'm very excited to hear people's presentations because there's some really cool projects people have been working on. Most of these are pretty exciting. And it's unfortunate we can't, you know, do the in-person expo, because that actually is a lot of fun, and, you know, having people from outside the department or outside the school come and look at this, it's usually a pretty high energy 2 hours, and just lots of enthusiasm, and that's always fun to work hard on something and then have lots of people come and appreciate it. And yeah, I think we're probably going to do a playlist for all the videos that people say we can share. I think we're going to make those available. But then you can't, like, have bowls of candy next to your presentation table. Quick refresher on the requirements of the presentation. So imagine that you're in the digital lounge and you have, you know, one of your posters up, and if you have some show and tell stuff, you've got that sitting on the table, and there's all these people walking around, and, you know, someone walks up to your table and they look at what's there and they read your poster and they're kind of interested and they say, hey, this sounds pretty interesting. Can you tell me about your SLP? Right? What do you say to them? So just say it to the camera instead. Very casual. Not looking for any specific requirements. Doesn't have to be a formal, you know, introduction, background, etc. Tell us about your project, right? You've been working on this, you've been developing it and thinking about it, and tell us what you're trying to do. What was the original idea? Did that idea change over time, and if so, how? What progress did you make? What were the setbacks you ran into? How far did you get on this? Where do you wish you had gotten to? What were the big things you learned? What were the surprises? Whatever you want to tell us, basically. It's just an informal conversation, but it's with the camera instead of with myself or Izad or, you know, someone from the Colombian or whatever. that make sense? Cool. All right, let's have some fun. So let's make a web browser, because it's Monday and we haven't done this yet. So let's make this GUI based. So I'm going to make a JFrame. Let's see, for the video, are we supposed to be in it, or is it alright to just narrate over a PowerPoint? At least put yourself in it in the beginning when you make the declaration whether you want this shared publicly or kept private. Okay, so state your name and which way you prefer. And then if you want to go to a PowerPoint, that's fine. I'm not going to require people to be in front of the camera. Alright, so there is is it fine if it's all screen share because I don't have anything physical? Yeah, screen share is fine, other than, you know, again in the beginning, go on camera, state your name, and state whether you want it shared or kept private. But yeah, it can screen share. That works fine. And don't get too worked up over the format or the style of the presentation. Okay, seriously, I just want to, you know, if we weren't doing SLPs but we were still face to face, I would basically have you come to my office and I'd say, you know, tell me about your SLP. What have you been working on? What have you been doing? And we would have a conversation about it. Okay, just pretend that we're doing that. Or, you know, you can talk to the dragon on my bookshelf in my office, or Albert Einstein in the corner. Very casual. Okay, I'm not going to, you know, grade based on what you're wearing, or, you know, your tone of voice, or, you know, you didn't begin with stating that you were at Clark College, or, you know, whatever. It's like, I just want to hear what you did on your project. And the points are basically, you know, saying that you did this part of the SLP, which is presenting it to me. And if you want, pretend like, you know, Bill Gates has shown up in the digital lounge with his checkbook in hand and is like, hey, what are you working on? Right? So how would you sell it? I don't know if we ever talked about elevator pitches, but, you know, this should be longer than an elevator pitch. But elevator pitch, if you're not familiar with the concept, right, is this question of, suppose you know, have an idea in your head, you've been thinking about this for a while, and you suddenly have, you know, the duration of an elevator ride with someone who could make this idea a reality for you. So, you know, 20-30 seconds, how would you describe your idea to the person in that much time, right? And that's an interesting starting point for something like, you know, a longer presentation. How do you really nail down the essence of this? How do you get someone's interest? But like I say, this is like 5 to 10 minutes, so it's not exactly an elevator pitch. But that can be a useful way to sort of think about, what do I want to say, right? And if you're working on a project that you might want to get funded somewhere down the road, or, you know, down the road as you develop other ideas that you do want to get funded, right? This is going to be something that comes up. You might get an appointment with a venture capitalist or a group of angel investors, and you're going to sit down in the room, and you're going to have a few minutes to convince them to give you, you know, $500,000 to seed your venture, and that's pretty fun. So this is all, you know, kind of practice for stuff that you'll probably be doing down the road. So have fun with it, right? It's exciting stuff. All right, so there's a class in Java called URL, right? It's URL, Universal Resource Locator. It's the thing that, like, you know, hyperlinks and the web and stuff are built on. And URL can be constructed with a string. Okay, that's promising. And it has methods that we can use, such as open connection, request a URL connection, and open stream, which gives us an input stream, which we know we can use to construct a scanner. Okay, so what is a web browser, right? It's a way to open connections to servers. Right, so I can type in a URL, right, Universal Resource Locator, with a protocol if I want, like use hypertext, and send a request to a server who will send me back information that looks like this. Okay, and it looks like this because this is how this program, which is called a web browser, which is named Firefox, is interpreting what comes back from Google. But what it's actually getting back is this, right? It's a bunch of mostly human readable text, which the browser Firefox interprets to display this. So if I go to astronomy picture of the day, right, which is a great site, by the way, you get all of this, but I'm using Control U to get to the source code, right? This is what actually came back from the browser. So it's a markup language. Let's see, so question, isn't HTML used for most of the displays on the internet instead of Java? So HTML is the language in which web pages are coded, right? So this text represents, you know, this page, and most web pages, you know, when you access a web page, you get back a bunch of HTML. That's what this first tag here says. It says all of this is HTML. Where this code comes from, right, is a different question. So in some cases, there's a file that contains all of this, and when I ask for a web page, it's simply the browser opens that file, reads the contents, sends it to me. Okay. In some cases, this is generated on the fly. Right? There's code running, and that code could be running in JavaScript, it could be running in Java, it could be running in Perl, it could be C, it could be something, you know, whatever, that's creating all of this text and then sending it to me. And it can be a combination, right? It can send me JavaScript, which the browser then executes and uses to create content, which turns into this. So a useful thing to be able to do is to read this stuff from a website, right? And we can interpret this a lot of different ways. So if you want to write a browser, right, one thing to do is to, you know, read this. Well, it says, you know, this is an HTML document. Here's a tag which says HTML. Somewhere there's a matching tag which says HTML with a slash in the end, right? And so the way, if you've never played with web pages before, right, these tags are paired off, right? Here's a title tag, and here's the ending title tag because it has a slash in the beginning, and everything between here and here is part of the title, right? So I can I can make a file, and I can paste all of this stuff in here. And now I can say, let's go to my file system. So instead of HTML, I'm asking for the file, and I can go to home, and I can go to Nick, and inside here there is a my file. I think I called it my page. mypage.html, which looks a lot like the astronomy picture of the day, except it doesn't have access to the picture. But if I come in here and I change my title to, you know, ha ha ha, astronomy picture of the day, and I refresh this, my title, go away zoom, is ha ha ha, astronomy picture of the day. So if you save the file locally, how would you update it? So I'm not sure what you mean by update it, but this is just a file on my hard drive, and the page I'm accessing in my browser starts with file : it's got the path to this file. And you know, I could come up here and I could hit enter, or I can just hit F5, or I can hit the refresh button, and it'll read from the file again. And so, you know, I can come in here. So H1 says this is the first level header. And so I can change that and hit an F5, and you know, there's a new web page. And there's really nothing magic to this, right? I can look at the source code of this, and you can see the code that I just modified. Right? It's just a file transfer. It's just that the browser is set up to interpret that HTML and display things accordingly. And if I change this H1 to be an H3, which is a smaller header, right? I get a tiny little header up here, but it's still bold-faced. All right, so let's play with the URL class tomorrow. Okay, we'll look at how we can use this to open a connection to a page like, you know, astronomy picture of the day, and pull down this information, and then eventually turn this into, you know, something like this. And it's really easy to do in Java because we've got classes that will do all of the hard work for us of, you know, interpreting the HTML and requesting the source code and so on and so forth. So we'll mess around with that tomorrow. It'll be a lot of fun. And we'll make a web browser by writing about 6 lines of code or so. All right. Have a good rest of the day. I will talk to you later. Are we using Beautiful Soup? I'm not. Are you? I don't know what Beautiful Soup is, so I'm pretty sure I'm not using it. I'm guessing it's a web page program. No, but I will check into it. Okay. No, we're just going to use very low-level stuff, basically from Java language and JavaNet. But yeah, lots of other packages out there we can use. All right, thank you everybody. Have a good one. Talk to you next time.